That's what I'm doing now. I'm sorry. Do you want me to start over again?
No. I think I got.
Okay.
All of the general questions that I was asking, you answered what I thought, but I wanted to clarify.
Okay. So what we've done so far is we've adjusted our ZPA program to be ZPA and PLC mode. We've recreated node 2. We deleted it as a ZPA module, recreated it as a PLC mode module. We deleted the ZPA mode add-on instruction and imported and then used the PLC mode add-on instruction. So now we have access to all the inputs and outputs in ZPA mode. Node 1, we are not going to change any logic. It'll be exactly the same. It's all it does is pass to another module. In our case, this time it'll be PLC mode. So in PLC mode, because it's all manual, we have to manually do all the logic for it. So first thing we will do is our photo eye logic. This would be for block and clear times for load positioning and then like the run after.
Oh, do you ever use insert?
I do.
Oh, okay.
I'll use insert for the ones where I don't remember where they are up here. But if they're up here,
lazy. I'm lazy, so I always insert everything. I'm just lazy.
I can't remember all the abbreviations correctly sometimes.
Yeah.
But like a message instruction or a bitwise distribute, things like that where I can't remember where they are. I'll use the insert.
Use the insert. I think if you just click on one of those lines, like on the wrong, hit the insert key on you type in BIT or bit. Oh, there it is. It's already there.
Yeah, so like, okay.
And then you just open up.
But if I didn't like a message instruction, I don't know where here, which one of these to open for a message.
Just type in MES.
But if I type MSG, it pulls it right up for me.
Yeah.
Goes it in. So that's the way I end up using the.
I'm lazy. I always, because I mean, man, sometimes you could be flipping through there if you don't know exactly. You know what I mean?
And if you ask an Alan Bradley guy if it helps you to quickly access information, there's no cheating when it comes to programming like that. So I'm going to open up the Node 2 add-on instruction. And since our flow is left to right, I want the input, sensor port, pin 4 left. This will be left block timer. New tag. Blocked. New clear timer. And of course, all the timer values are going to be your system specific.
Do you want to examine it when it's closed for the clear? Okay. There you go.
Paste. And this would be the sensor port right pin 4.
Uh-huh.
So this is our photo eye inputs. So whenever I, especially doing it like this, like with a module, I always like to grab my inputs, set my logic, then or do my logic, then set the outputs.
Mm-hmm.
So the next logic we will do, and I'll need, because I don't remember my add-on, so let's look at our controller tags. But I believe I have them separated. Let me look. Input. Upstream module forward and upstream module reverse. Perfect. So all up here will be downstream module forward and reverse. Perfect. So I don't have to grab those because I already have that information. So the next thing we would do is jump. Start and this is where I'll use the first scan bit from the logic main.
Mm-hmm.
We'll latch that in for ourselves. And this is where I do is this mandatory? No. But if it's actual a zone like ZPA, and ZPA does a search routine to look for a stranded load, I also do that in PLC mode if there's a possibility of a stranded load. So that's what we're going to do here. So it's our start dwell. New timer. And since our modules are using a 5-second jam time, I make my start dwell a 5-second timer. Done. Under etch. Paste. So if I have the first scan jump and at my label, as long as I have my first scan, run our timer.
Mm-hmm.
And our first, if this is timing, our photo eye is empty. Run the motor. So the first condition for running the left and right motors will be on the left motor. If this timer's timing, and the left eye is clear, Node 2, output, run motor left. Copy, paste. The timer's timing and the right sensor is still clear. Run the right motor. And so this is the basic. Grab our sensor status. And notice how during this start dwell where I'm searching, I'm not using the photo-eyed logic. I'm using the direct sensor bit. I'd like doing that so it stops quick. Sees the eye and stops. I'm not relying upon timers at this point. So now it's time for our actual logic. So the logic will go in between the jump and the label. Since our system is a push system, we will do a compare. And what are we going to compare? Input, upstream module status going forward. And I don't know if I have a leftover tag in here. Please be there. I do not. So I'm going to create a tag. Zone status. And I like to call it an integer with an array of 7. So then when we open it up, we have 7 integers. And then what I do is status 1 is value 1. And that means the sensor is clear, the motor stopped, the zone is empty. Status 2. So zone status array 2 gets value 2. Kind of see where this is going now. The photo eye is clear. The motor is running. I'm accepting. Array 4, value 4. The sensor is blocked. The motor is running. I'm discharging. Array 5, value 5. The sensor blocked. The motor stopped. And accumulated. Status 6. Value 6. I'm busy. So now when I come here, I go to zone status. And since I'm looking for status 4, I'm looking for upstream to be pushing, discharging. I just select status 4, which is preloaded with value 4. So that's how I use that zone status tag. Array 4, value 4. I could, because it's an equal, I could have done something like this. So if the upstream module in the forward direction is discharging, then I do something. So when they're equal, you can put it doesn't matter if which one's on top.
Oh, you don't just show the component description.
Yeah. And my left eye is not blocked. I want to accept the load. and then we have to seal it in. So if upstream's a status 4 discharging and my eye's clear, begin accepting. And if I'm accepting, continue to accept until my eye becomes blind. And the reason we do this is because once this sensor clears, this will become status 1 or 2, which would make this run false. So we use the accept to seal it in. Now it comes time for the tracking part. We want to grab the tracking. I want to show you kind of the way when I do this, I'd kind of do it like the card does. So you have to kind of show how it works. But once you see how it works, you can definitely modify the logic to work differently. Mm-hmm. So that'll be up to you. But this would be kind of how the cards would do it. So if I'm accepting, and I'm going to put this back the correct way because it's in the upstream status does not equal 4, which means now the sensor's cleared. And I'm going to call this tracking one shots and make it an integer for now. Oh, it already exists. Ooh. Okay, perfect. Tracking one shot. Oh, it's a Boolean. Controller tags. Tracking one shot. Where's my tracking? Cancel. That should be home. That's being used someplace else. Sorry about this. I need a one shot. Let's call this PLC for PLC mode tracking one shot. We'll do it that way. So we'll use the tracking at 0.1. And now here's what we do. We will do a move instruction. Input. Upstream tracking. So this is the tracking from node 1. Mm-hmm. In ZPA mode, I said to accurately read and write tracking data, the zone must be accumulated. Mm-hmm. In PLC mode, it's slightly different. You don't have to be accumulated because you know the real data. It's one at a time coming to you, and then it's up to you to make sure you move it to the correct locations. And this is so what this is saying is when I'm accepting and the upstream zone is no longer has the eye blocked, that's when tracking is available. That temporary register, that's what this is. And we're going to get it. And we're going to call this left temp tracking. Because now we have the tracking data from node 1. Next step. When the eye becomes blocked, copy paste. Our second one. we're going to move the left temporary tracking to left at eye tracking. Now the tracking is at the photo line. And clear the temporary registry. We can, if needed, we can do math, divide, mask move, and we can take the left at eye tracking, 16 pound, 1, 2, 3, 1, underscore 1, 2, 3, 4. This will be the left sequence. 16 pound, 1, 2, 3, 4, 1, 2, 3, 4. Left location. Next step. If the left eye is blocked, and the right eye is not, we will move from the left to the right. And again, we'll do a little seal in. And then we have to do all of our tracking part. Now, all this extra tracking logic is only if you are using tracking data. If your loads do not have tracking data that you're trying to preserve, all these extra steps with this tracking is not required. Still with me, Taylor? Still there, Taylor?
Yeah.
Oh, okay. Okay. So, okay. I want to make sure I didn't hear you there. I want to make sure you didn't lose
I'm here.
Okay. So what we're going to do is we will continue with the tracking part. So this will be as if I'm moving left to right and the left eye clears, couple moves.
Okay, so in PLC mode, you have to do the
You have to do all the hard work.
merging
Right.
or the transfer.
The transferring of the logic, yes.
Does people do that? Why would they just use ZPA?
Well, there are times when like diverters and things like that where you would want to do this. And again, I'm kind of showing this as how the cards do it. We could eliminate a couple steps and just here I have the tracking data. It's for my left eye. Now my eye clears. I have no more left tracking. Move it to right tracking. You could make it real cut and dry.
Mm-hmm.
But what I like to show is how it actually works with a card. This actually completely works. And you as a programmer can then decide, oh, I really don't need that. Just delete that logic.
Okay.
So this is like a basic example for you to fine tune later.
Mm-hmm.
So then we have our left at eye tracking. We'll move that to the right temp. and then clear the tracking at the left eye.
Mm-hmm.
And then here, bit. When the right eye becomes blocked, one shot. Paste. We're going to move the right temporary to right at eye. And clear the right temp.
Mm.
So you kind of see that. And with mine, and then the next one would be, and I'm going to go, even though I don't have anything to discharge to, I'm going to go ahead and put the next step in, which would be something here. There we go. Input. Downstream module status going forward. That equals zone status 1, meaning it's empty. And my right eye is blocked. Discharge the load. And because this zone status will go from a 1 to a 2, which would turn this logic off, we're going to, again, seal it in. And we're going to keep discharging as long as our sensor's blocked.
Mm-hmm.
And then we could also, what we should also do here, delete. I'm going to leave this here. Is yes. Paste. Paste. So once we start our discharge, we are going to move the right eye tracking to output. Discharge tracking. And move this. And what happens is now that we're discharging and we have our tracking in the output register,
Mm-hmm.
when the eye actually clears, this will automatically get moved down to the next module, and the next module would grab it and use it just like we did.
Mm.
So now we are probably 85% done.
Mm-hmm.
One thing we have not done yet is when else do our motors run? So the only time we run our motor so far is on the first scan. Well, the left motor is going to run when we're accepting a load.
Mm-hmm.
And the left motor is going to run when we're moving from left to right. The right motor is going to run when we're moving from left to right.
Mm-hmm.
And it's also going to run when we're discharging. We're almost done. We've got our inputs. We did our jump so we can find a stranded load.
Mm-hmm.
We have our logic to accept loads, grab the tracking data, and I'm going to copy this one and paste it so we can look. So right eye and right at eye. This would be the right sequence number. This would be the right location. So that way we can see it.
Mm-hmm.
Now we have 2 more rungs of logic to write. 1. Bitwise, no. Nope. There we go. So what we will do is left photo eye. We're going to act just like a card.
Mm-hmm.
If the sensor's not blocked and the motor's not running, what zone status is stopped and not blocked? Status 1, empty.
Mm-hmm.
Where's this going to, where are we going to move it to? Output, upstream status.
Got it.
If the eye is clear, but the motor's running, that is zone status 2. Copy, paste. If the eye is blocked and the motor's running, that's status 4, discharging. If the eye is blocked, but the motor isn't running, that's status 5, I'm accumulated. Now we need to put one more in here. If the timer is timing, this is because we're doing our search routine. Well, that's status 6. I'm busy.
Gotcha.
So we automatically, based just like the documentation states, based upon photo eye state, based upon the motor state, we're writing the correct zone status. This way the cards will handshake and pass loads just like they're all in ZPA mode. The ZPA card won't know that this is PLC mode because it's talking just like a ZPA card would.
Mm-hmm.
Copy, paste. Well, this instead of the left photo eye, because it's the downstream of the right side. All of this logic would be based upon the right photo eye and the right motor. And this status is output. Oh, I passed it. Downstream status. Let's verify our controller, see how many mistakes I've made. Ooh, look at that. Very nice. So what we would want to do first is easy roll, refresh. And something I did, oh, I'm sorry, I'm not plugged in. During the break, I don't know if you remember, when we were first talking about, we had our node 2, it was showing up. Come on, connect. There it is. Okay. There we go. It was showing up 1 sensor, 2 motors. Well, that would mean this card only had an upstream side. I wanted to, so what I did was add the second sensor and made it 2 zones. That way this logic, it would be more applicable for 2 zone cards. If it comes time for you have a 1 zone card, you can delete some logic. I would rather show you logic that you can delete than you have to create new logic on your own. Deleting is so much easier.
Okay.
So that's why I changed this part of it. But now we need to go to advanced dialog, connections. Say this is in PLC mode. If we lose connection, all off. Do not clear connections. I want node 1 and 2 to talk to each other. That's the purpose of this kind of logic. And apply. This can't be undone without a backup or auto configure. Okay. And this reason it shows not responding is because the processor is doing the reset, so it lost the connection to it.
Okay.
And now we're in PLC mode. Perfect. So now we can save our program. And of course, I already have the right path in here, so we will just download. And you should hear the motors behind me. Once this goes to run mode, you should hear the motors start running, doing the startup routine. Yes. Hear the motors? That's the startup routine working. So now what we can do, so we're at right tracking. So this is our node 1. You can see we have good connection, no triangle of death. And our toggle is off. Let's go ahead and we'll just go with this. we'll leave it with first one. Let's do this. It'll be sequence 3. So let's say location 33. So it'll end up becoming sequence 3, location 33. So I'm going to first, let me make sure my conveyors are moving slow because they're real small. Okay, very good. So everything is nice and slow. 1 second. Let's see. Please bear with me.
Mm-hmm.
Sorry about that.
Mm-hmm.
The conveyor that we're using is kind of configured for multiple products, and I had to change how a sensor was connected so things would work right. So the first thing we're going to do is I've just added 2 loads to the ZPA card. So we're accumulated. We have an arrival. We incremented to sequence 3. We're going to release with sequence 3 and location 33. And let me do one thing here, just to make sure all this works right. I want to verify my sensor state. Yes, the left is clear, and yes, the right is blocked right now. Perfect. Wanted to verify that.
Mm-hmm.
So if we go back to release, this tracking number should change. And you should hear motors running behind us. Excellent. So we do have a 4th arrival. Let's make it location 44 for now. And if we go to PLC mode, we could see currently the left sensor is blocked. And I have 0 tracking data. input, temp left, and the left eye becomes moved to at eye. Ooh, that doesn't look good. What did I do wrong? So upstream is status 5. We're going to write a 4 and a 44. Let's release it. So our tracking data did change. And again, I received no tracking data. Input to the module status upstream going forward. Oh, dummy. The tracking data is not available until it's not a 4. I said equals 4. Duh. You should have caught that, Taylor. You should have caught my programming mistake. This was an equal statement. That should be not equal. So let's set this up again. This time it'll be 5 and 55. Toggle. I just released. PLC mode. Oh, there's tracking data. Sequence 5, location 55. And as soon as I clear this right sensor, we now have nothing in the left. We have no right temporary, but we have right at eye tracking. And we have the 5 and the 55. So we've passed our data. So if we go back to our ZPA module, let's do 6 and 66 and release. And we can look at our left eye, and we have 6 and 66. So sorry about that, using the wrong instruction there. But that was a good example of troubleshooting, I guess. I copy pasted, and I didn't change this to not equal. So as soon as I've made it the not equal, boom, you can see all the tracking's working now. So this is an example of how you interface then between ZPA mode and PLC mode. Unfortunately, all of this logic that's already built into the card, we have to rewrite it in the PLC to do PLC mode. To do it correctly. Once you learn, well, then I don't need this piece of logic. I can delete that, or I can delete this. But I would rather show you the full way, the 100% correct way. And now that you know, you could go back and start fine tuning, maybe deleting some wrongs. This was just for us to look at. We could delete this. Or maybe this would be check this location number. If the location's 55 and that's me, instead of passing it to the downstream, instead of moving right to left, maybe I should have diverted. So you're going to have to, add your own logic, your own conditions. But this is kind of the basic logic to get all this happening. Hopefully this wasn't too much to take in at once. Like I said, I'm definitely going to share this with you when we're done. So you can.
Oh, that's fine. I can always reference the recording.
So be able to reference this.
Yeah. If I don't miss or don't unmix, and I can always come back.
Yeah, definitely. You're reviewing it. You have your questions. just send me an email. Hey, Tim, in our program we worked with, the ZPA PLC program, in this run, what does this really do? Just ask questions. I mean, that's what all this is for. It's a learning experience.
Correct.
What I would like to do now is I'm going to go ahead and save this one.
Okay.
Let's take us a 15-minute break. And when we come back, I will use, instead of rewriting logic again, I'll go ahead and use a pre-written program. I'll just explain what everything is doing and then go live and show you how it's working.
Okay. All right.
All right. So, let's take a 15-minute break and we'll come back at 2:15.
Yeah, you want to pause your recording?
I sure will this time. Here we go. Oh, not yet.